3, 2, 1, good morning! My name is Mr. Boder. Welcome to 9th grade physical science. Here's what we're doing today. As you can see, we are going to describe what's happening on a phase change graph using the kinetic theory of matter. We haven't really learned about this yet. We've collected a phase change graph data, and we should have graphed it with that freezing and melting lab, the TOP stuff, right? We're going to now explain what the heck was happening. Here's your very first note. We're on the phase change note sheet. Get that note sheet out if you don't have it. Here's your first note. That's not the first one. This one's the first one. The kinetic theory of matter is that all matter is made of particles which are in constant motion. Parentheses matter. That could even be just like vibrations. All matter is in constant motion. All matter is in constant motion. Wait, does that mean that this wall right here is moving? It looks pretty still to me, you guys. What if we zoomed in and we looked at just the atoms of that wall? What would we see? The atoms are vibrating. They're stuck in place. They're in the grid of that substance, but they're vibrating in place. All matter is moving. The air particles, the particles that make up this air, are they moving? Yeah, they're actually moving a little more freely. They're bouncing around, bouncing off the wall, bouncing off each other, flowing around. What about the molecules in my coffee? The liquid molecules, are they moving as well? What if I get it totally perfectly still and there's no vibrations? Are they still moving? Yeah, they're bouncing around off each other, flowing around each other constantly. You can actually measure this. You can see it. If you take a microscope and you put in just a tiny little piece of dust into a tray of water, and you get it so there's no vibration in the whole room. And you watch that piece of dust, and guess what happens to the piece of dust? It just bounces around a little bit. And it has this little, it's called Brownian motion. It just has this random motion. And that's caused by the motion of the water molecules bumping into it randomly. And they bump it around. We've known about that for quite a while. Okay, that's the kinetic theory of matter. All matter is made of particles. They're always vibrating. What's your next note on that sheet? What's the next note?
What is energy?
Okay, we got to talk about energy. I'm building a story here. I'm going to give you a couple building blocks early, and then we're going to tie it together in a story later on. Energy is the ability to cause change or do work. That's what I'm talking about for energy. It's the ability to cause change or do work. You'll notice that it's an ability. So could you hold energy in your hand? Is it a substance you could hold? No, and sometimes it's hard to point to and be like, that's it right there. Energy is like a state. It's like a state of being. It's a condition, is what it is. It's an ability to cause change or do work. Do I have energy in me today?
Yes.
Yeah, where did that come from?
Sleep.
I ate breakfast. There are chemicals in that food. Carbohydrates, fats, proteins, thank you, I was searching for the third one, that have chemical energy stored in them. They're large molecules. I ate them. My stomach is breaking them apart. And then other parts of my body will reform new molecules, releasing energy. I have energy because of that. Hold on a second, I've got a weird example over here. That's a stored energy. It's called potential energy. Look at this. I've got a textbook here. Does it have energy right now? Oh, no. We're going to go straight out into the field. Can you pause it, would you?